Now we'll learn 5 important theorems on this chapter. Okay, so there are 5 very important theorems. Hello everyone, welcome to our math class. In today's class we are going to learn the chapter Loci, locus and its construction. Okay, so let's first see the definition. Locus is the path traced by a moving point which moves so as to satisfy the certain given condition. Okay, that means on a plane, suppose we have a point P. Okay, now under certain given condition, this point P will move in a curved line, curved path, or in a straight path. Okay, so these are the two possibilities, whether this point will trace a curved path or a straight path. Okay, that means according to this, the locus is nothing but it is a line. Okay, it may be curved line or a straight line. It depends on the given certain given condition. Okay, so first one is the locus of a point equidistant from a fixed point is a circle with the fixed point as a center. Okay, so here our condition is, okay, the condition is the point must lie equidistant from a fixed point. Okay, so suppose this is our point P. Okay, and the fixed point is O. Now this distance is equal. Now keeping this distance equal, the path traced by this point P is a circle. Okay, let's see. Okay, let us construct this locus. Okay, this is our fixed point O. I'll keep the compass at O, and this is our rotating point. Okay, P. So now this point P can move in this path. Okay, so that means in this way the locus of this point P is a circle. Okay, so this is the first theorem. That means the locus of any point equidistant from a fixed point. From a fixed point means here we are talking about one point. Okay, this is the first theorem. Now second theorem, the locus of a point equidistant from 2 points. Okay, here it is about 2 points, is the perpendicular bisector of the line segment joining the 2 points. So this one is the very important theorem. Okay, so here the given condition is 2 points. We have a 2 points. Suppose this is our 2.1 point is A and another point is B. Okay, so when we join these 2 points, we will get a line segment. Okay, so let us join this 2 point A and B. Okay, so when I join these 2 points, we will get a line segment. Now according to theorem, the locus of a point which is equidistant from these two, okay, is always a perpendicular bisector of this line segment. Okay, that means now we are going to draw a perpendicular bisector of this line segment AB. Okay, so let's see how we draw the perpendicular bisector. Okay, for that, okay, we have to take a compass and okay, expand this compass so that it must be less than the length of this line segment and more than the half of this line segment. Okay, we cannot keep the compass like this. Okay, it should be longer than the half of this line segment but shorter than the whole line segment. Okay, so I'll keep this length. Okay, so first we'll draw the arc on both the side of this line segment. Okay, one arc here, another arc here. Okay, similarly now taking the same compass, okay, got the previous arc like this here and here. Okay, so now when we join this intersections of two arc, we'll get the perpendicular bisector of line segment AB. Okay, so this is the perpendicular bisector of line segment AB. Okay, this is the very important. We have to learn to draw the perpendicular bisector. Okay, so according to this theorem, the locus of any point equidistant from two given point is the perpendicular bisector of the line segment joining these 2 points. Okay, so this is also how we draw the perpendicular bisector. Okay, let us verify also. Okay, verify means let us prove this also. Okay, That means any point on this perpendicular bisector is always equidistant from both A and B. Okay, so I'll take some point here. Okay, suppose this point is P. Okay, this point P lies on anywhere on this perpendicular bisector. Okay, so let's join this. Okay, PA and PB. Okay, so I'll join this PA and PB. Okay, so by joining this PA and PB, we got two triangles. Okay, and suppose these two triangles are congruent, then by CPCT we can say PA and PB are equal. Okay, so let's see. Okay, first in triangle, okay, let us this point be M. Okay, so let in triangle APM and triangle BPM, first equal is this 90°. Yes, angle M. Okay, I'll write only angle M. This is equal because both 90°. And second one is PM is equal to PM. This is common. Okay, this is common to both the triangle. And third one, okay, and the third one is AM is equal to BM, because this is a perpendicular bisector also. Okay, bisector means it will exactly cut this line segment at the midpoint. Okay, so this is also perpendicular bisector. Okay, so therefore this triangle APM is congruent to triangle BPM by angle side angle. Okay, SAS. So this imply PA is equal to PB. Okay, by CPCT. Okay, that means any point lying on this perpendicular bisector is equidistant from both the points A and B. Okay, so this is the second theorem, and this one is very important theorem. Why? Because according to this theorem here, we learn to construct the perpendicular bisector of line segment. Okay, now theorem 3. The locus of a point at a given distance from a given line is a pair of lines, one on each side of the given line and parallel to it at the given distance from it. Okay, so here our given condition is a line. Okay, we are talking about only one line. So this is our given line. Okay, this is our given line. Okay, so this is a given line means our point may lies on either side of this line. Okay, let us suppose this point. Okay, the point is lying on a given distance. Okay, let given distance be 3 centimeter. Okay, so that means this point may lies on this side or this side. Okay, so point P may lies on this side as well as this side. Okay, any side. So that means according to this theorem, locus of this point is a parallel lines, okay, to this given line. That means it's a simple one. Okay, so everywhere the distance is only the 3 centimeter, so that means we will always get a parallel line. Okay, and which is equidistant from given line. Okay, so this is given line, so our locus is either this one or this one. Okay, so this is from a given one line. Okay, so let's see another theorem. This is number 4. Okay, number 4, the locus of a point equidistant from two parallel lines. Okay, here in first theorem there is only one given line. Here the given line are two lines and which are parallel. Okay, and two parallel lines is the line parallel to the given lines and halfway between them. Okay, so that means here our given condition is two lines which are parallel. Okay, so this is one line. Okay, I'll draw another line at a 1 2 3 4 5 6. Okay, at a distance of 6 centimeter apart. Okay, so this is another line. These are actually our given lines which are parallel to each other. Okay, so this is line L and this is line M. Okay, so according to our theorem, the point must lie equidistant from both the lines. Okay, so both the equidistance from both the line means it exactly lies at the mid of these two lines, that is at 3 centimeter from both the lines, because our total distance is 6 centimeter. So this distance is 3 centimeter, and similarly this distance is 3 centimeter. Okay, so this is our point. So the locus of this point is a parallel line. Okay, also a parallel line which is parallel to both the given line. Okay, so this is our locus of point P. Okay, this is our locus. Okay, and the last theorem. Okay, this is theorem number 5, and this is also very important theorem. Okay, so here we talk about parallel lines, and in theorem number 5, the locus of a point equidistant from two intersecting lines. Okay, so as we know that in a plane we can, if we have to draw a pair of line, that line may be parallel or intersecting. Okay, so parallel we have done. Now this is intersecting line. Okay, the locus of a point equidistant from two intersecting lines is the bisector of angles between the lines. Okay, so as we know that when we draw two intersecting lines, there must angle is formed. Okay, so let us draw that angle only. Okay, so this is our one line, this is one line. Okay, let us see, this is another line which are intersecting at point O. Okay, so that means here angle is formed. Okay, so these are two intersecting line. According to this theorem, that means locus of any point equidistant from both these lines is always the angle bisector. Okay, that means now here we are going to draw angle bisector. Okay, so now we are going to learn how to construct angle bisector. Okay, and that's why it is very important theorem. So first we'll put our compass at point O and draw a arc which intersect both the lines. Okay, so that means this is our first arc. Okay, it intersect both the lines or arms of an angles. Okay, so again now we'll put the compass here, first intersection point. Okay, so we'll put the compass here and draw a arc here. Okay, in between the angles, between the lines. Okay, so again put the compass at another point of intersection here and then cut the previous arc. Okay, so now we got our angle bisector. So this is our angle bisector. Okay, so this is our angle bisector, that is the locus of point. Okay, which lies equal distance from the intersecting lines. Okay, now if you have to prove this, means any point lying on this line, suppose we will take point P here, so this point is always equidistant from both the intersecting line. Okay, so let us prove this. So let us draw this distance. Okay, distance is always perpendicular, so here also draw this distance perpendicular. Okay, suppose this is A, this is B. Now we can easily prove these two triangles are congruent. Okay, POA and POB. How? This is both 90 degree. One, this is common 2, and these two angles are equal. This is a angular bisector. Okay, so that's once these two triangles are congruent by CPCT, this PA and PB are equal. Okay, so these are all theorems in chapter Loci. Okay, now we are going to solve few questions. Okay, now let us solve few questions. Okay, so the first question is from the board paper 2017. Okay, so let's read the question. Using a ruler and a compass only, this is a construction based question. That means the first instruction is always like this only. Okay, so we are going to use only ruler and compass. Okay, now the question is, construct a triangle ABC in which AB is 7 centimeter, angle CAB is 60 degree, AC is equal to 5 centimeter. So okay, that means first we have to construct a triangle. Okay, first let us make a rough figure. Okay, we will always make a rough sketch first. Okay, so that means this is our rough sketch. So this is A, B, whichever side is given, we will consider that as a base. Okay, so here AB is given, so this is AB 7 centimeter, angle CAB, this is CAB means this angle is 60 degree, and AC is 5 centimeter. First we are going to construct this triangle. Now the second part of the question is like this: construct the locus of point equidistant from AB and AC. Okay, this is our AB and AC. Okay, that means AB and AC are two intersecting line, and here angle is formed. That means we have to draw the angular bisector of angle BAC. Okay, and the second question is point equidistance from BA and BC. BA and BC means two intersecting line intersected at B. That means here angle B is formed. That means we are going to draw or construct the angular bisector of angle B. Okay, so let's start. Okay, we already know how to construct angular bisector. Okay, but first of all we are going to construct a triangle. Okay, so given triangle, so first we will draw the base. Okay, so base is 7 centimeter. So first our base is 7 centimeter. So this is 7 centimeter base. I will draw from here. Okay, this is our base AB 7 centimeter. Okay, so we'll mark the point. This is A, this is B, and its length is 7 centimeter. Okay, now we are going to construct 60 degree angle from point A. Okay, so let us construct 60 degree angle from here. Okay, first we will put our compass at point A and draw a semicircular arc. Okay, so okay, this much is okay. Okay, now we will put our compass at the first point of intersection here and then mark or cut this arc. Okay, so this is our 60 degree angle. Okay, now this is 60 degree angle, and also this AC is given as 5 centimeter. So that means from here we will draw a line segment of 5 centimeter. Okay, so this is our 5 centimeter as well as 60 degree angle. Okay, so this point is C, and then let us join BC, then our triangle is completed. Okay, so this is our given triangle. Okay, now we are going to construct angular bisector of angle A as well as angle B. Okay, so this is the locus of a point equidistant from AB and AC. AB and AC. So we are going to construct angular bisector. Okay, this first arc is already there, so we will use this arc only. Okay, so that means to draw a construct an angular bisector, first arc is already done. So we will keep our compass or put our compass here and then draw the first arc here. Okay, so this is our first arc, and then putting our compass here we will make another arc to cut this arc. Okay, so this is angular bisector of angle A. So this is first part. Okay, now this done. Okay, now this is first number 1. Now number 2 is point equidistance from BA and BC. This is BA and BC, that means angular bisector of angle B. Okay, the process is same. First we will put our compass here and draw a arc to intersect both the arms of an angle. Okay, so this is our first part. Now we will keep our compass at the first point of intersection and then make another arc here. Okay, and then another arc from this point. Okay, another arc from this point, and then cut the previous arc. So this is here. Okay, now we are ready to draw our angular bisector. So this is our second angular bisector. Okay, so this is how we complete our first question. Okay, this is question from 2017 paper. Now the next question, this is from 2018 paper, and the first instruction is always the same, using ruler and compass only. Construct triangle ABC such that BC is 5 centimeter, AB is 6.5 centimeter, and angle ABC is 120 degree. Okay, so here BC as well as AB is given. That means either BC or AB will take as base. Okay, so I'll take BC as a base. Okay, so let us draw a rough sketch first. So this is our first triangle, BC as a base. Okay, here angle ABC is given as 120 degree. That is 120 degree is a obtuse angle. So our angle is like this. Okay, so this is 120 degree angle. Now this is our A, and which is 6.5 centimeter. Okay, and this is 5 centimeter. And then let us join AC. So this is our triangle. Okay, so this is our triangle. Now next part, construct a circumcircle of triangle ABC. That means in this question we have to draw a circle, circumcircle. Okay, circumcircle means a circle which passes through all the three vertices of this triangle ABC. Okay, so this is like this. Okay, all the three vertices. Okay, then construct a cyclic quadrilateral ABCD such that D is equidistant from BA and BC. Okay, that means we have to construct a cyclic quadrilateral. Cyclic quadrilateral means a quadrilateral whose all the four vertices lies on the circle. Okay, A, B, C are already on a circle, so we'll mark D somewhere here and then join this. This is our complete construction. Okay, so let's start. Okay, now first we are going to draw base BC as 5 centimeter. Okay, so first base BC. Okay, so this is our base BC 5 centimeter. Okay, I'll draw from here. Okay, okay, so this is base BC 5 centimeter. Okay, now let us mark the point. This is B, this is C. Okay, and it is 5 centimeter. Now we are going to make 120 degree angle from B. Okay, so to make 120 degree angle from B, we will first put the compass at point B and draw a semicircle. Okay, so this is our semicircle. Now from here, this first cut this arc. This is our 60 degree. Okay, to make 120 degree, again we have to put our compass at this point of intersection and then again cut this arc. So this is our 120 degree. Okay, so BA, this is 6.5 centimeter. So from here we will draw a line segment of 6.5 centimeter. Okay, so this is our 6.5 centimeter, and which is 120 degree angle. Okay, so this is 120 degree as well as this length is 6.5 centimeter and this point is A. Okay, now join AC. Okay, so now let us join AC. So our first part is done. Construction of triangle ABC is done. Okay, now this question, construct a circumcircle of triangle ABC. That means now we are going to construct a circle which passes through all the three vertices, that is A, B and C. Okay, so for that we first have to find out the circumcenter. Okay, center of a circle actually. So to find the circumcenter, what we have to do is we have to draw the perpendicular bisector of any two of the sides of this triangle. Okay, this triangle has three sides. Okay, we are going to draw a perpendicular bisector of any two of its sides. Okay, so let us draw the perpendicular bisector of AB and BC. Okay, so first I will draw the perpendicular bisector of BC. Okay, so we know how to draw a perpendicular bisector. Okay, we have to take a length of a compass little more than half of this BC and less than the half of BC. Okay, so here one arc here, one arc here, and then from B. Okay, same compass, without changing its length, we draw the another arc to cut the previous arc. Okay, so here we go. So now we have our first bisector, perpendicular bisector of BC. Okay, so this is first perpendicular bisector of BC. Now again we are going to draw the perpendicular bisector of either AB or AC. Okay, so I'll draw the perpendicular bisector of AB. Okay, so that means I'll take a compass at B first and then measure this length. Okay, so this is more than half, less than in length of AB. Okay, so one arc here, another arc here, and then from point A with the same length of compass we'll cut this arc. Okay, here and here. Okay, so this is our second perpendicular bisector. Okay, so let us join this. Okay, here. Okay, this is our second perpendicular bisector. Let us extend this first perpendicular bisector. Okay, so wherever these two perpendicular bisector intersect, that is our center. Okay, so this point is our circumcenter O. Okay, so now taking O as a center, okay, O as a center, and then measure OA as a radius. Let us draw a circle. This is our circumcircle. Okay, so this circle must passes through all the 3 points. Okay, so this is how we draw a circumcircle. Okay, this is our circumcircle. Now next part. Okay, next part is construct a cyclic quadrilateral ABCD such that D is equidistant from BA and BC. Okay, so here BA and BC means two intersecting line. Okay, two intersecting line means we are going to draw angular bisector. Okay, so BA is, this one is BA and this one is BC. So we are going to draw angular bisector of angle B. Okay, so we know how to draw an angular bisector. Okay, so first, okay, this first arc is already there. Okay, so actually we can draw from here also 60 degree, because this is 120 degree. If we draw a line from here, that will be the angular bisector of angle B. Okay, so but we'll follow the whole procedure. Okay, so here first ray is already there, so that means we'll draw another ray here. Okay, one here and another from here. Okay, so this is where it get intersected. Okay, so let us draw this. Okay, this is our angular bisector of angle B. Okay, so and this meet the circle at this point, so this point is considered as D. Okay, so here this is our D. Okay, now let us join CD. This is CD and AD. Okay, CD and AD. Okay, this join. Now this ABCD is our cyclic quadrilateral. Okay, so this is how we complete our question from 2018. Okay, this much for today. So we'll solve few more questions in our next video. So till then, keep practicing and thank you very much.